Hello, everyone. In this lesson, we're going to talk about two powerful tools for understanding probability. We have tree diagrams and we have Venn diagrams. In example 1, we're going to look at tree diagrams, and example 2, we're going to look at a Venn diagram. Both of these tools help us organize the information so that we can solve more complex probability problems. Tree diagrams specifically help us when we have events that happen in a sequence and we have some conditional probabilities, like choosing one item after another. And then Venn diagrams, on the other hand, are great for analyzing groups that maybe overlaps with different sets. Let's start with tree diagrams. Let's see. So some key concepts with tree diagrams. We have that each branch represents a possible outcome. We have probabilities on branches from the same node should add to 1, and that will make sense when we go through our example. I'll point that out to you. Same thing with the last two. It's going to make more sense once you see the actual example. But another key concept, to find the probability of a specific path, we're going to multiply the probabilities along that path. And that's when we have a sequence of events. We multiply each event as it happens down the path. To find the probability of multiple outcomes, we're going to add the probabilities of each relevant path. So in example 1, we have a costume improv game. There are 6 role cards placed in a hat. 2 are labeled witch, 3 are labeled pirate, and 1 is labeled unicorn. We have 2 actors. Each randomly draw 1 card from a hat, one after the other, without replacing the first card. We're going to draw the tree diagram to show the possible outcomes of the 2 selections, and then we're going to use our diagram to answer the following questions. Okay, so we have 2 witch cards. I'll label it as W. We have 3 pirates. I'll label that P, and 1 unicorn. I'll label that U. And that gives us our total of 6 cards. When we create a tree diagram, we have nodes, and the first node, I like to call that the start button. So here's our node. Now, when the person draws the first card to see the first role they're going to play, they have 3 options. They could choose a witch, they could choose a pirate, or they could choose a unicorn. This is the first pick, so I'm going to highlight it with this dashed line so you can see that this first set of branches represents the first pick. So this is our node, and the branches coming off of that node, once we label the probabilities on there, those probabilities need to add up to 1. Now, on the first pick, since we have 2 witch cards, there's a possibility of 2 out of 6 for choosing a witch card. So that's our probability for witch. That's 2 out of 6. If we choose a pirate first, the probability of choosing a pirate first is 3 out of 6. And since there's 1 unicorn, the probability of picking a unicorn the first time is 1 out of 6. Now, these probabilities need to add up to 1, so let's double check because all of these branches are coming out of the same node. So we have 2 over 6 plus 3 over 6 plus 1 over 6. So if I add the numerators together, that's 2 and 3 is 5 plus 1 is 6. That gives me 6 over 6, which is 1. So far we're in good shape. Now, this is where we're going to draw our second level of branches, and this will represent our second pick. So here are the nodes for each of the next set of branches. Let's look at the witch first. we're going to make the assumption that we're picking a witch first from the card. Once we make that assumption that we picked a witch first, then we have 3 more choices. We could choose another witch, we could choose pirate, or we could choose a unicorn. Now, because we know on the first pick we picked a witch, we are now down to 1 witch because we took that card out, and now we have a total of 5 cards. So the chance of picking a witch now is 1 out of 5. Now, because this is conditional, we're making the assumption that we already picked a witch card. This is the probability that I pick a witch the second time, given that I picked the witch the first time. That probability is going to give me 1 out of 5. Now looking at picking a pirate the second time, the probability of choosing a pirate second, given that we already picked a witch, if I look at what's left in the box, I know that I already picked a witch, so we're down to 1 witch card, but we still have all 3 pirate cards. So this is going to be 3 out of 5. Now for the unicorn, there's still 1 unicorn left if we assume that we picked a witch card the first time. So the probability of picking a unicorn the second time, given that I picked a witch the first time, that's going to be 1 out of 5. Now, if I add up all of these probabilities, 1/5 plus 3/5 plus 1/5, that gives me 5 out of 5. All of these branches are coming out of this node that signifies that we picked a witch the first time. Now, let's look at if we pick a pirate the first time. So now we're looking at this branch right here. We are going to make the assumption that the next set of branches from here is that we picked a pirate the first time. So once we pick a pirate the first time, we have 3 options. We could pick a witch, we could pick a pirate, or we could pick a unicorn. The probability that we choose a witch the second time, given that we already picked a pirate the first time, if we come up here, actually let's reset this. Now we're picking a pirate the first time, so I want to change it from 3 pirates to 2 pirates. We still have 1 unicorn with a total of 5 cards. So if I look at the number of witch cards we have, assuming that we just picked out a pirate card, that's going to be 2 out of 5. If we assume that we pick a pirate the first time, the probability of getting a pirate the second time, if we look up here, we have 2 pirates left because we took 1 out. So 2 pirates out of 5, so 2 out of 5 cards. That would be the probability of choosing a pirate the second time. Now, for the unicorn, there's still 1 unicorn left. So the probability of choosing a unicorn the second time, given that we picked a pirate the first time, that's going to be 1 out of 5. Now, let's make sure, because all of these branches came out of the same node, we have 2/5 plus 2/5 plus 1/5. When I add the 2, and the 1, that gives me 5 out of 5, so that's 1. All right, let's pick a different color. Now we're going to come down this track here, where we're going to pick a unicorn. So our options are that we pick a witch, a pirate, or a unicorn. So when we're looking at this set of branches, our assumption is that we picked a unicorn already. So the probability that we pick a witch the second time, given that we already picked a unicorn, if I look at what's left up here, let's adjust our totals again. So we're going to reset it so that we have our 3 pirates back. But since we picked a unicorn, we're going to have 0 unicorn cards left. So the probability that we pick a witch, given that we picked a unicorn, we're still going to have 2 witch cards out of 5. So this is going to be 2 out of 5. So picking a pirate, the probability that we pick a pirate the second time, given we picked a unicorn the first time, that's going to be a 3 out of 5 because we have all 3 pirate cards left, because we're making the assumption that the card that we first picked is a unicorn. Let me give myself a little bit more room here. All right, so now we're looking at picking a unicorn the second time, given that we already picked a unicorn. So the chances that I pick a unicorn the second time, given that I picked a unicorn the first time, that's going to be 0. That's going to be 0 because we have no more unicorn cards left. So this, I'm going to make our dashed line here. So all of these branches between these 2 dashed lines, this is all of our possible second picks. And depending on what branch we're looking at, we're going to have some conditionals. So all of these branches that we just discussed, all are based under the assumption that we picked a unicorn first. All right, let's go to the next branch up. So looking at the middle branch, that is where we made the assumption that we picked a pirate card first. So all of these conditional statements are based on the fact that we picked a pirate the first time. Then back up here, all of these conditionals are based on the fact that we picked a witch card first, and that's why we came down this green branch. Now, to find all the possible outcomes, we're going to list them. This is the probability that I pick a witch card first and a witch card second. And that probability is what I get when I take and multiply down those branches. I have 2 6 times 1/5 when I multiply down that path. That's going to give me 2 30ths. Now, if I look at this outcome, this is the probability that I pick a witch card first and a pirate second. So when I follow these branches down to that outcome, I take 2 6 times 3/5. So that's going to give me 6 out of 30. Looking at this outcome, I have the probability that I pick a witch first and a unicorn second. When I multiply down that path of branches, I have 2 6 times 1/5. That's going to give me 2 out of 30. This set of outcomes here is when we're looking at a pirate first. So this is the probability that we pick a pirate first and a witch second. I multiply down those branches. I'm going to get 3 over 6 times 2 over 5. That's going to give me 6 over 30. When I look at the next set of outcomes, this is the probability that I have a pirate first and a pirate second. When I multiply by those probabilities, I have 3 over 6 times 2 over 5. That's going to give me 6 over 30. Now, this next one, that's where I assume we pick a pirate first and a unicorn second. When I multiply by those probabilities, I get 3 over 6 times 1 over 5. That's going to give me 3 over 30. All right, now we're on to our last set of branches. Here's our last set of outcomes. This is where we assume we pick a unicorn first. So this first one is we pick a unicorn first and a witch second. So when I multiply those probabilities, I have 1/6 times 2/5. That's going to give me 2 over 30. This next outcome, I have the probability of getting a unicorn first and a pirate second. When I multiply those probabilities, I get 1 over 6 times 3 over 5, which is 3 over 30. And then this very last one, this is the probability of picking a unicorn first and a unicorn second. And we said that that was a 0% chance. So here we just made a probability distribution. We listed all of the possible outcomes with all of the probabilities. If I add all of these probabilities up that we just came up with, the 2 over 30, 6 over 30, 2 over 30, etc. If I add all of those up, I should get 30 out of 30, which is 1. All right, now let's use our probability entry diagram to answer the probability questions above. Question 1 says, what is the probability that the first actor draws a pirate? So we're looking for any of the outcomes in which a pirate was drawn first. So we're looking for the probability of the outcome P1 and a witch the second time, or the probability of getting a pirate the first time and the second time, or the probability of getting a pirate the first time and a unicorn the second time. When we look for these probabilities are provided by the paths taken down each of the branches. So those were already multiplied, but when we're finding multiple outcomes, that is this right here. To find the probability of multiple outcomes, right? We have 3 of them here. We're going to add the probabilities of each relevant path. So this means we're going to find each of these probabilities and add them together. So looking down here at our tree, anywhere where we see a pirate was picked first, that's what we're looking for. Here's pirate and a witch, pirate and a pirate, and then pirate and a unicorn. So those are the probabilities that we need. So a pirate first and a witch second. We said that was 6 out of 30. Then we're going to add that to pirate and pirate. That was 6 out of 30. And then the pirate and the unicorn, that was 3 out of 30. When we add those up, we get 15 out of 30. All right, question 2. What is the probability that the first actor draws a pirate and the second actor also draws a pirate? So we're looking for the probability of P1 and P2, which we already found. That's 6 out of 30. Question number 3. What is the probability that at least one actor draws a unicorn? So let's find any of those outcomes where we have at least one unicorn. So here's where we have at least one unicorn, that green shade. I'm going to highlight these in light green. Here is another one where we have a unicorn is drawn. And then we have these down here where a unicorn is drawn. So we need to add up all of these probabilities. We have 2 out of 30 plus 3 out of 30 plus 2 out of 30 plus 3 out of 30 plus 0 out of 30. So that's 10 out of 30. Last question. Given that the first actor drew a pirate, what is the probability that the second actor draws a witch? So this is conditional probability. We're trying to find the probability that a witch is drawn second given that a pirate is picked first. So that is also on our chart that we already figured that out. I'll use purple for this. If a pirate was picked first and then a witch second, this is the branch in purple that gives us that conditional probability, and that is 2/5.